Okay, so we're going to go over chapter 6, analyzing and interpreting quantitative data. And then next week, we're going to go over two chapters. We're going to go over chapters 7 and 8 together for qualitative data. So just know that. But we'll go ahead and get started here with finally, we get to analyze some quantitative data, which is like my favorite part about research. So let's learn some about that. So here's your objective. So just know that statistics can be challenging, but just don't be overwhelmed. Okay, that's just only one step in analyzing your quantitative data. You also have to prep the data. You will run an analysis, report the results, and discuss them. And then when you're analyzing your quantitative data, you have to prep the data for analysis, okay? So this is when you assign numerical scores to the data and input it into a program for analysis. And we'll go over all the different programs that you can use. And after that, you'll analyze the data. And then finally, you get to report the results, okay? So that's kind of what we're going to be doing in a nutshell for this chapter. So, how do you prepare the data for analysis? So, we've got 11 slides to talk about that. First, you have to score the data. So, the slide is just talking about that. And when you assign a numeric score, it's also known as its value to each response. It's called scoring. So, you have continuous scales. That's like if you said strongly agree and strongly disagree, and then you had like a continuum in the middle. So you'd give it a 5, a 4, 3, a 2, and a 1. Okay. Or if you had a categorical scales, that's like if you had a female, you'd give it a score of 1. And if they are male, you would give it a score of a 2. And that's just how you interpret the data, or how you can score it so then you can interpret the data, okay? You can also create something called a code book. That way you can write down how you're scoring all the information, so that way you can go back and refer to it and look and see and stay consistent with your scoring. Okay, so here's figure 6.1, and it's on page 174, and this is an example of a code book. Okay, so before you analyze the scores, you have to figure out what type of scores to use from their instruments. You do this so you know how to enter the data into a computer program. We are presented with three types of scores in table 6.1 on page 175 in your book. There's a single item, summed, and different scores. So a single item score is an individual score applied to each question for each participant in the data. In the example, you would give a score of 1 for yes or 2 for no. So it's pretty simple. Then sum scores, are scores added over several questions to get a holistic view. Then there are different scores, and these represent a change in the individual's responses. So, like, kind of if you did like a pre-test and then a post-test, those are examples that would use a difference score. So, after the data is scored, then you get to select the computer program that you're going to use to analyze your data. Here's some guidelines to consider. Number 1, look for programs that have tutorials on how to use it. Number 2, something that is easy to input data into is nice. Number 3, make sure the program analyzes the types of statistics you're performing. Number 4, be sure to analyze the quantity. You can analyze the quantity of data that you have. Number 5, be sure it fits in your budget, because not all of these programs are free. They do have discounts for grad students, so you could look for that. And we'll talk about one in particular in a minute. Number 6, use something your campus uses. So you can always see, what does my campus use, and then use that because they'd be familiar with it. Okay, so here's some of the most popular programs. And hint, 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 on the quiz, it's going to ask you what's the most popular program, and it would be SPSS right here at the top. Okay, so just know that that's super popular. A lot of campuses choose to use that one. And they do have one for grads that would be more like the grad pack. It's said in your textbook, and it would give you a discount. Okay, so kind of just go check that out and look at that and see how much that would cost. That's what I used when I did my doctorate, my dissertation. It was SPSS. Okay, so once you've had the responses scored, now you can input the data into a computer program for analysis. Okay, it resembles a grid that you would see in Excel spreadsheets. So you use your code book again to assign the numbers to categorical data. Here's an example in Table 6.2 and in Figure 6.2 on pages 178 through 179. So it's like a table. They've given them the scores, smoke 1 for yes, 2 for no, or however they did put it in their code book. So just know that, so you can see gender 1 or 2, so that's male or female, okay? So after all the data has been entered, you have to check for errors. Okay, that makes sense. This could be scores given that are wrong according to your code book. So you just go in and you scan it and make sure there's no errors or missing information. So you clean up the database. This is a term used when you look for scores that are incorrect. Okay, you can do this visually. You can even use the SPSS sort cases feature to organize the data so that you can see easily if they all fit within the range that you need. Such as if there are only 5 options and you have a score of 6, then you will know there's an error. Okay? Then you may stumble across missing data, which may be due to the fact that the participants failed to give the answer required. If this happens, you can eliminate that participant score altogether. Research states that you can substitute up to 15% of the data without skewing the data. Okay. Now let's analyze the data. So now we get to go on and analyze it. You need to look at descriptive statistics. That's describing the trends in the data. You'll look at inferential statistics and you would analyze the data from your sample to make conclusions that would apply to the whole population. So your inferential is applying it to the whole population. You can relate 2 or more variables and also examine variables through more advanced statistical analysis, and we'll kind of give an overview of those. So let's examine each of these data analysis methods in more detail. First, we'll look at descriptive statistics, which will help you understand where your scores stand compared to other scores, trends in your data, and how varied your scores may be. They measure the central tendency or the score that represents the entire distribution, which are the mean, median, and mode. And so it's a very fancy way of saying you're going to be looking at your average, what scores are in the middle, or what scores happen most often. So just know that that's kind of what descriptive statistics looks at. So you know that. You just might not have known that that's what type of statistics that is. Okay. It also measures the variability or the spread of the scores through the range and the standard deviation. And you'll see that represented like with the words SD on analysis outputs, the standard deviation. So your range is the difference between the highest and lowest scores. Okay, so if you have like a 5 and a 10, the difference would be a 5. That would be your range. Your standard deviation is how far the scores are from your mean or your average. So how far do they go away from that average? Okay. Next, in descriptive statistics, they also measure relative standing, which describe one score relative to a group of scores through percentile rank, standard scores, and z-scores. So a standard score it lets you compare scores from different scales. A percentile rank is the percentage of participants that are at or below a particular score. And then a z-score lets you compare scores from one instrument to another instrument. Okay. So here's figure 6.3, and it portrays the statistical procedures that you can use to provide descriptive statistics. And this is on page 182 of your textbook. And here's figure 6.3, and this portrays the statistical procedures that you can use to provide inferential statistics on page 182. And These are a lot of different ones that we'll talk about, like your t-test. You'll get very familiar with that. Parametric, non-parametric. Your analysis of variance, that's like your ANOVA, okay? Your Pearson scores, that's very popular. Spearman-Rowe also. And then multiple regressions, those are pretty popular, okay? Here is 6.3, and this is showing you procedures that you can provide inferential statistics, and this is on page 182, like your chi-square analysis. Okay, so that's a popular one that I'm familiar with, that actually have ran. Okay, and your pi coefficient also. Okay, so here's a bar chart showing you categorical scores of the variable parent status. So these were put in a category where they married, divorced, or separated. And then you can create figures in your research that kind of represent this, so it's easier for those reading your research to be able to see the data. Okay, so you're familiar with bar charts. Okay, so here's what we call a normal curve. One of your questions on your quiz, hint, hint, it's going to ask you how much fall within the standard deviations within normal range without being on the two outside outliers. So you can see 2.5% is out here, 2.5% is out here. So a normal one would have 95% being in this central area, okay? So this is an example of scores that are graphed on a bell-shaped normal curve. This is called normal distribution or normal probability curve. So just know that's kind of what happens whenever we, and remember, standard deviation is you want to see how far they go away from the mean. So your mean is here in the middle. So how much go this way, how much go this way, and then they just chunk it out into these different sections. And 95% should be within these first four columns in the middle, okay, on a normal curve. Now, continuing on, so inferential statistics analyze groups or two or more variables to make conclusions about the whole population. So you measure a sample population carefully chosen from the overall population. They measure through hypothesis testing and confidence interval. Hypothesis testing is a good way to see if the sample mean is a good estimate of the population mean. In confidence interval testing, you determine the range where your population score may fall. The effect size tells us how different our samples are and help us to see if it applies based on our participants' measures and effort to collect. So inferential statistics also measures the effect size. So there are 5 steps to hypothesis testing. So number 1, you want to identify your null and alternative hypothesis. Number 2, set the level of significance or the alpha level for rejecting the null hypothesis. 3, collect your data. 4, compute the sample statistics. 5, make a decision if you're going to reject or failing to reject the null hypothesis. And we'll go over some examples of this. So in this figure is a normal curve showing sample means distributed of all possible outcomes if the null hypothesis is true. Most of the sample means would fall in the center of the hypothesis if it's true. For example, any sample of smokers and non-smokers' depression scores would be similar and would fall in the middle if that were your hypothesis. Okay, so the curve displays a two-tailed test with an alpha equal to 0.025 at each end. The larger middle part of the graph is labeled as high probability values fall if the null hypothesis is true. The left and right tails are labeled extremely low probability values if null hypothesis is true. That's your critical region, which implies or rejects your null hypothesis. Okay. So here is a figure 6.6 on page 191, and it shows 20 test scores from 2 groups based on 2 teaching methods. You can do a t-test to see if the scores from the 2 groups are different. SPSS does this for you. That's what's great about those programs. You just input the data and then it does all the work for you. So pay attention to the means. Now, your book does go in to show you how to do all of those statistical procedures, but just know that there are programs that do it for you. The mean difference of the groups was 7.7. So if you have the average from group A and group B and you subtracted it, the difference is 7.7. You can see that there on the graph. So the null hypothesis for this test was this. There's no difference between teaching method A and teaching method B on test scores. So they're looking at group A, their teaching method, group B, their teaching method, and then those are the scores of the participants. There's 20 total. So the table shows the following scores, and you can see them, okay? We're going to go and look at for more data. So this is all on page 191 of your textbook if you want to look there also. So here are all the results of the t-test that they did. The two-tailed significance test indicated a t-test score of a negative 2.93 with 18 degrees of freedom, resulting with a two-tailed p-score of 0.009. You see that right here? Okay. Which is the probability, so p stands for probability, okay? That the result could have been produced by chance if the null hypothesis was true. So the p-value is statistically significant because it is less than the alpha of 0.01. So an alpha of less than 0.05 is the level of maximum risk you're willing to take that any difference are due to chance. Okay, so you don't want things to happen due to chance, so they test for that. And so your score needs to be, sometimes it's below 0.01, sometimes it's below 0.05. It just depends where you set it and what type of testing you're doing. Like if you're doing something on, let's say, medicine and the effects of it, a new medicine, then you would want to have a lower p-value because you don't want to have any risk happening, okay, that you're willing to take. So we have a 0.009, which is great. If your p-value is less than the alpha, you reject the null hypothesis and vice versa. So we can say there is a difference between teaching methods given the two groups' results and reject the null hypothesis. Remember, your null hypothesis was there's no difference between them. Well, we're rejecting that, and we can prove that and say that because our p-value is less than the 0.05 or 0.01, whatever they decided to put it at. I think for this they did 0.05. So we get to reject it and say that's false. There is a difference between teaching methods. Okay, so that's why we do these type of scoring and then testing and analyzing, and we get to test our hypothesis, and it gives us very important information, which is pretty cool. Okay, so let's move on. This is table 6.7, and this is an example of using the chi-square statistics. So it's just a different type of analysis. Earlier was your t-test. This is your chi-square. So this test is looking at non-smokers and smokers, and they're based upon their parents if they're married or not. So they're like, okay, does parental status determine if somebody's going to be a smoker? Okay, that's what they're trying to figure out. So here's their null hypothesis. There's no difference. Remember, null means no. They're trying to say there's nothing, null, okay? So there's no difference between the number of smokers and non-smokers with regard to parent status. So they're trying to say that there's no difference between if you're a smoker or not if your parents are married. Okay, that makes sense. So you can use SPSS to analyze this data for you also. In this part of the table, you're given the observed count and expected count. Okay, so you can see that here. Expected counts, okay, and then the observed counts. It's the one above it, an expected count, okay. You do this with the formulas provided on page 193, okay. So they get those expected counts by plugging in different numbers, and it calculates it for you. But SPSS will calculate this for you, okay. And so let's move on and see what we found once they ran the analysis of the chi-square. So the Pearson chi-square test value is a 3.86. So here it is. This is an important number right here. With degrees of freedom, DF, of 2, with a resulted p-value, remember that's your probability or significance value of 0.15. Okay, so that's important. Remember, your alpha level is the maximum level of risk that you're allowed, that the differences are due to chance. Okay, so this should be less than 0.05 or your set amount, like we talked about. So with the p-value of 0.15, that's higher. So what does that mean? Your test results are not statistically significant, okay? And you have to accept your null hypothesis. So there is no difference between smokers and non-smokers' marital status. So whether being married or not does not impact whether you're a smoker or not. Okay, so we rejected that one. Okay, I'm sorry, we accepted that null hypothesis because our results were not statistically significant. We couldn't reject it. Okay, so that's pretty neat. So you got to see both sides of the coin on that. Okay. So it may be tricky to decide which statistical test to use because, like, why would you use the t-test over the chi-square test? Okay. You have to figure that out. It's important. So look on table 6.5 on page 189 for guidance on how to do that. Also, there's an appendix B. This is super important on page 616 in your textbook, and this provides common statistical tests used, their definitions, and it also provides an example. So that's this really great resource. So remind you, Appendix B on page 616 of your book, okay? There's 7 questions to answer deciding on which test to use. So ask yourself these questions. Number 1, are you comparing groups or variables in your hypothesis or research questions? So depending on your answer will determine what type of test you need to do. Number 2, how many independent variables? Number 3, how many dependent variables do you have in one research question or hypothesis? Number 4, are you going to control statistically your covariates? Number 5, how are you going to measure your independent variables? Okay. Number 6, same thing. How are you going to measure your dependent variables? And then lastly, are your scores normally distributed on a normal curve? Okay. So all of those answers will help you figure out what type of test you need to do. And then just look at those charts that we talked about. So it's important to consider errors that can occur when you're doing a hypothesis testing. Okay. So type 1 error is if you reject the null hypothesis when it's actually true. Okay, you need to be careful for that. Type 2 is if you fail to reject the null hypothesis when it's actually false. Or power is when you correctly reject the null hypothesis. So just be aware of potential errors. And then here's a chart on page 194 of your book, and this is 4 possible outcomes that can occur when hypothesis testing. So you have confidence intervals. They help you decide how large the difference is. It is the range of upper and lower statistical values estimated to pertain to the actual population. This is given as a percent, meaning 95% of the mean differences would fall between the lower and upper values reported for your t-test. That's an answer that we talked about earlier for your quiz, okay? It's not only important to see if the test results were statistically significant through the p-values and the possible range of acceptable scores, the constant confidence interval, but it's also necessary to determine the effect size, or the strength of the difference between the two means or variables. The difference means to determine if it is meaningful. For a t-test, you would use the formula here to determine the effect size, okay? So tables, whenever now you get to report some of your results. And one way you can do that is by using tables. So they summarize your results in quantitative data, and they're organized in rows and in columns. You need one table per statistical test. Give a title and clear headings. Use your APA manual to see examples of descriptive tables and inferential tables, so they'll look different. Provide notes to explain your information as needed. Figures present information in graphs or in visual pictures. Tables are preferred to figures because they provide more information in a simple form. Refer to your APA manual for guidelines when creating figures. Figures should not have distracting information, and they need to be easily read, and understood. Examples of figures include bar charts, scatter plots, line graphs, and charts. Presenting your results of your descriptive and inferential statistical analysis is important. At a minimum, you should state if the hypothesis was significant, give information about the analysis performed, and use language normally used when reporting statistical results. On page 199, figure 6.7 gives examples of results statements for both descriptive and inferential statistics. So you could just plug in your results into these examples, and that could help you write up your analysis results. Once you are done reporting your data, you have to conclude the study with a summary of your key findings, your explanation of results, any limitations, and recommendations for future research. The research ends with implications, which are suggestions for the importance of the study for different audiences. After the summary, you can explain why the results occurred the way they did. Here, you can return to a theory you suggested in the beginning, perhaps. You could also discuss the existing literature and how your study compares. You also need to state in your study's limitations, which are potential weaknesses or problems within your study. This could be maybe the loss or lack of participants, small sample sizes, etc. These are useful to other researchers who are considering conducting a similar study. So maybe they want to reproduce the study, but they want to do it in a different way, because they wouldn't want to replicate it or duplicate it. So they could maybe get a different sample size and etc. Okay. So stating your limitations is a good bridge to recommendations for future research. These are suggestions you make about additional studies that need to be conducted. And this is also how you can come up with ideas on what research to conduct also. Okay. Is to look there on the end of their studies. And so, let me see. Here is how the study compared based on what you just learned, if you go and look at that study there. So that is it for this chapter. I hope this helped you, and good luck with your assignments and taking your quiz. You'll do great.